Okay, so today we're going to look at finding inverse matrices by hand, which is the most painful part, so let's just get the pain out of the way. All right, a 2x2 matrix is not painful, I don't believe. I think there's a shortcut. There is. So an inverse of a 2x2 matrix is just actually really easy, because if my 2x2 matrix has these coordinates or elements, A, B, C, D, the inverse I'm not going to write it again. Everybody knows that the thing that looks like 2 to the negative 1 power means inverse, right? Is actually equal to 1 over what we call the determinant, which is the multiplying the diagonals and subtracting them, A times D minus C times B. And then we do this little trick. We switch the A and the D. We switch the A and the D. We leave the others alone but negate them. It's just a formula for the inverse of a 2x2.
Who came up with like
This,
that's not right.
and then you do the scalar multiplication, yeah.
What is the function of this? What is
I'm going to show you. I'm going to show you. There is a purpose to find inverses. And this is probably the one thing Dr. Shanta showed you on your calculator, how to solve systems using inverse matrices, yeah.
So why do, if say A is 2, why do 1, oh wait.
I'm going to show you. This thing is actually has a name. It's called a determinant. So let's just learn by example. Find A inverse if A equals 1, 2, 3, 4. I don't know why I'm stuck on 1, 2, 3, 4.
It's good.
It's just easy.
Good's very good.
So let's follow the formula. 1 over, what's 4 times 1? 4 minus 2 times 3, 6. Switch the A and the D. Negate the others. So this is really negative 1/2 times the 4, negative 2, negative 3, 1, which will be negative 2. What am I making a fraction? Negative 3/2, positive 1,
Isn't that
negative
no, isn't it
1/2.
3 halves? Because it's a negative 3 times negative.
Oh, positive 3/2. You're exactly right. Sorry. So that is the non-painful way to write to find an inverse of a 2x2. That's not painful at all. Yeah. I'm not sure I'm going to do a lot of testing on it, maybe one single problem. I want to show you, remember how I told Henry that if you multiply a matrix and its inverse, you will always end up with the identity? Let's test it. Put your phone away, please. I mean, it's pretty obvious. Put it all the way away. Thank you. Can y'all work on this? What is 1 times negative 2? Move. 2 times 3/2 is just 3, right? Negative 2 plus 3 is 1. 1 times 1 is 2 times negative 1/2 is negative 1. 1 plus negative 1 is 0. So far, so good.
Miniature.
Row 2, column 1, negative 6. What's 12 over 2? Positive 6. Negative 6 plus 6 is 0. 3 plus a 2, a negative 2, will be 1.
So it's miniature.
So it's what?
A miniature version? Because you don't see like the third column.
Oh,
third row.
yeah. This is the 2 by 2 identity.
Is there more than
The 3 by 3
3
is,
by 3?
yeah, 4 by 4. It's only for square matrices.
Is it like the same thing though? Or is it different?
She did 2 different.
If you multiplied a 3 by 3 times its inverse, it will give you the identity matrix, yeah. However, finding a 3 by 3 inverse is not for the faint of heart.
I have a very faint heart.
So what if I want you to find A inverse if A is a 3 by 3?
Then I'd not answer the question.
Leave it blank and get the extra credit right. Exactly.
I copied it wrong. The top one is negative 4, negative 6, negative 3, 6, 15. All right. No, y'all, if you fully embraced the 10-3 stuff, you might not think this is horrible. But what we do to find an inverse is, and I want to save paper. What I do is I just augment this and throw down the identity right beside it. Then, I'm showing you the process. We're gonna morph this side into the 1 0 0 0 and 0. So we've already done at least half of this. What's goal number 1 gonna be?
Get the 1. We got it.
Done. What's goal number 2?
Get the 0.
Zeros here and here, right? So 1, negative 2, negative 4. Leave the stuff alone, right? What are we going to do to get rid of that 2, people? Row 2 minus 2 row 1s. Is that what I heard you say? So negative 2, positive 4, positive 8, negative 2, 0, 0. So we're going to add those. We get our 0. 4 minus 3. Oh my goodness. 8 minus 6 is 2. Negative 2 plus 0. 0 plus 1. So you just have to, the only additional part of this is that there's 2 extra columns that we just have to keep going through. The process is really not any different. Everybody with me? What is our next goal?
The other 0.
0 instead of the negative 3, right? We've used rows 1 and 2. We got to use row 3, right?
Row 3 plus 3
Row 3 plus 3 row 1s. I like it.
0.
3, negative 6, negative 12, 3, 0, 0.
It's beautiful.
Add those. Oh my goodness. 0 here. 0 there. 3 is gorgeous. 3, 0, 1. Everybody agree?
Yeah.
Well, so first part done. We do need row 3 to be divided by what? 0, 0, 1, 1, 0, 1/3. Ooh. We might be getting a little ugly. But now we can't stop. Like we stopped at row echelon form before. Now we have to move up and get the zeros. My thoughts are, because I want to save paper, I'm going to now use the new row 3. What would I multiply the new row 3 by to cancel out a 2?
-2.
-2. So row 2 minus 2 times the new row 3. -2, -2/3, -2. Everybody agree when I multiplied them? So now add these. 0, 1, 0. -2 minus 2 is -4, 1, -2/3. Next, multiply the new row 3 by 4. Y'all do that. Multiply this one by 4 to cancel the row 1. So sorry. Okay, thank you. They're already here for you. I'll continue to record.
So all you're doing is getting the zeros out, right?
Yeah, well, yeah, here, and then the last goal would be there. And to get it there, we're going to only use row 2, right? Does that make sense? Because we got to keep the zeros. Have you gotten it? What is this? 4, 0, 0, 4, 0, 4, positive 4/3. So 1, still -2, 0, 5, 0, and 4/3. And one more step and we're done. I multiplied the new row 3 by 4, right? And added it to the row 1. And now we're going to use the row 2 and multiply it by positive 2, right? Row 1 plus 2 row 2 will give me 0, 2, 0, -8, 2, and -4/3. Add those 1, 0, 0, -3, 2, 0. That was nice, wasn't it? Keep the others the same.
Is that it?
And that is it.
Can I go to the bathroom?
Yes. So A inverse is what's left over here. -3, 2, 0, -4, 1, -2/3, 1, 0. Is that 1/3? So, tedious, but is it really anything new? No, it's not new. It's just tedious. Do we still have those same places to make one silly error in step 1?
Yeah.
So the whole rest of the thing is off? Yes.
What's the point of getting this though?
There is a point, and it is in this section, so might as well do it. We can use inverses to solve systems of equations, because well, first of all, shall we test it and make sure we get the identity when we multiply?
Nope, I tried.
-3
Yeah, I tried.
plus 8 is 5. 5 minus 4 is 1. 2 minus 2 is 0 plus 0. 0. Positive 4/3, -4/3. Looky there. -6 plus 12 is 6, minus 6 is 0. 4 minus 3 is 1, plus 0. 0. Positive 2, negative 2. 9 minus 20. What's 9 minus 24? Negative 15 plus 15 is 0. Negative 6 plus 6 plus 0. Last one, 0. Minus 4 plus 5.
1.
We got it right.
I guess there's
All right.
one, I just do it somehow.
All right. So, what is the point? There is a point, especially if we have a calculator to solve, okay? Because we know that A times A inverse gives the identity. What if I had the identity and I multiplied it by X, Y, Z? Yeah, it's still recording. Yeah. If I multiply the identity times X, Y, Z, I get 1X plus 0 plus 0, 0, Y, and 0, 0, Z, right? So, if I have a function, a system, that is 5x plus 7y plus 4z equals 1, 3x minus y plus 3z equals 1, and 6x plus 7y plus 5z equals 1. What we can say is that the matrix 5, 7, 4, 3, negative 1, 3, 6, 7, 5 times x, y, z will equal 1, 1, 1. Agreed? This is like a different way to write this because 5x plus 7y plus 4z equals 1, right? I'll give you a chance to write that down and get it, because I know I write like the wind. But if I can find the inverse of this thing, I know when I multiply it, it gives me the identity, correct? And so if I multiply both sides by the inverse, then it will give me the answer. So, let's practice one more 3 by 3 inverse. I will allow you to use the calculator on all but one on the homework. So, I'm going to do my work down here so I can show my answer up there. I'm going to try to work through this quickly. If y'all would rather not copy it down, you'll see it I'll have it. We got issues because there's no 1. All of our others have been so beautiful to start with a 1. But I am seeing, if I say row 3 minus row 1, what am I going to get? A 1. 6 minus 5 is? 7 minus 7. Oh, how beautiful. 1. 0 minus 1 is?
Negative
0 minus 0, 1 minus 0.
1.
Everybody feel good about that?
That was wild.
That was nice. So now, I have used both rows 1 and 3. I gotta use 2. How do I want to cancel out a 3?
2,
To get it to 0.
1 half the row.
Oh, you are going to cancel this one by saying 2 times, or negative 2 times that. That'll work. I was going to say, the new row 1 times the negative 3 plus row 2. So negative 3, 0, negative 3. Positive 3, 0, positive 3, right? Negative 3, sorry. Plus this would give me 0. Oh, looky there. 1. Oh, wait. Negative 1. Negative 3 plus 3. Oh, my goodness. 3 plus 0. 0, 1 plus 1. Negative 3 plus 0.
This is wild.
Now, I liked your thought process. You said if I multiply this by negative 2 and add it to row 3, it will give me the 0. All right. So row 3 minus 2 row 2. Negative 6 plus 2. Negative 6. 0. Negative 2. 0. Did I do that right? We've used all of them, but we have to have 3 lines. So we have to use all of them at least once. 0, that 9, that's not beautiful. Negative 1, 0, negative 2.
Isn't it 5? Yeah, don't we need to use 1? Because it's 7 minus 2.
It's a negative 2 times negative 1 is positive 2. Right?
Yeah.
So, I'm seeing row 1 is done for now. Row 2 is almost done. What's the only thing we need to do to row 2? Yeah. Yeah, negative row 2. Negative 3, negative 1, positive 3. Is that right? Might be nice to write legibly. This one, got to get that to be 0. Can we just say row 3 plus 9 times row 2? 0, negative 9. 9 times 3, 27. Negative 27. 0, 0. Oh, nice. 27, 7, negative 26. Everybody good so far?
Yeah.
Oh, y'all, this is not nearly as bad as I was. When we didn't have a 1, I was so worried. Row 3 is almost done. What should we do? Divide it by negative 1, right? Negative 27, negative 7, positive 26. Everybody good so far? Row 2. Stick a fork in it. It's done. The only thing we got to get rid of is that 1 right there, isn't it? And we got zeros in row 3. That's the one we're going to use, isn't it? Just row 1 plus the old row 3, right? 1, 0, 0. What's this one? 26, 7, and negative 25.
That was wild.
So,
Yeah.
so the idea is, if we trust our work, this is our inverse, right? So, if I multiply this A inverse here by that, it's going to give me the identity. So now I'm going to take my A inverse.
Can you go up more?
Go up more. This is a 3 by 3 times a 3 by 1. Gives me a 3 by 1, correct? 26 plus 7 is 33. Minus 25 is 8. Negative 3 minus 1 is negative 4. Plus 3 is negative 1. Negative 27 minus 7 is negative 34 plus 26. So guess what X, Y, and Z are? 8, negative 1, and 8.
It's max.
Negative 8. Was that a negative 8?
Yeah, negative. Bottom.
The bottom one is negative 8? Oh, yeah. The bottom one is negative 8. The top one is positive 8. Done. So there is a purpose for finding the inverse. In terms of all of the work required to find that inverse, not my first choice.
It ain't worth
Unless I have a calculator. If I have a calculator, it might be worth that trouble, right? Matrix A was a 3 by 3. 5, 7, 4, 3, negative 1, 3, 6, 7, 5. I am going to check matrix A now because I'm not always great on putting it in. 6, 7, 5, right? The answer matrix was a 3 by 1. Let's put that in as B. One, 1, 1. Don't think I need to check that one, do I? So, matrix A inverse times matrix B. 8, negative 1, negative 8. Let's go. Was it worth it to know this inverse if we're allowed to use the calculator on a 3 by 3? Absolutely. This is a pretty streamlined method of solving a system if you're allowed the calculator. Yes. 2 by 2s, I would never choose to use inverse matrices. Never. But, you know. So I'm going to assign, do I need to show you a 2 by 2 using the inverse to solve it? I'm going to assign a couple of those, or one.
Don't I get to use calculator now?
No calculator.
Oh.
Is that the one question you can't use calculator on?
There's going to be two. One 2 by 2 and one 3 by 3.
Oh, okay.
That's a let's keep going.
Yeah, I was bored.
Yeah, we should go on Alvin.
All right, so
Well, I
let's
said
do
let's
this
do
one
that,
by hand without a calculator. What do we do to find the inverse? Oh. What do we do to find the inverse of a 2 by 2, people?
You get the determinant.
Switch the 9 and the 7. I'm sorry, and the 3.
You're struggling.
I'm struggling. Switch the 9 and the 3. Negate the others. Multiply by 1 over. I will write the 3, 4, 7, 9. Yeah, 27 minus 28 is negative 1. 1 over negative 1. Well, that's just negative 9, positive 4, 7, negative 3. Here's our inverse.
That was so.
What are we multiplying the inverse by to get the answers? 10 over 20. It's not 1 and 1, 1 on this one. So negative 90 plus 80 is negative 10. 70 minus 60 is positive 10. There we go. X equals negative 10. Y equals positive 10. Can we check it? Negative 30 plus 40 is 10. Negative 70 plus 90 is. So if we can find the inverses like this, not bad. But I still wouldn't choose inverses to solve a 2 by 2 for some reason. Got too many other, easy. So I'm going to assign some problems from the 10-5. I might lower the assignment since you, I had to cram a little bit. So from the 10-4 section, page 670. Even if there's something different on Blackboard, write this down. Sorry to interrupt your phone conversation.
Oh, no, it's
But-
not, it's not a conversation. I'm doing something.
All right,
Oh, gee.
Nah.
tonight's, the new one will be I'm just going to get you to do number 6. And then 9
What?
through 21 odd. I'm not making you do a 4 by 4. 25 only. 31 only. So far, non-calculator. And then 33, 37, and 38 is a 4 by 4. Y'all think y'all can do that one on a calculator?
Oh, yeah.
These are on calculator. All right. And y'all even have a few moments. This is instead of Blackboard. This was actually what was assigned from the 10-4, but I think this is probably slightly less than what I have for 10-5.
I'll take your lunch real quick, B.
So,